Could you imagine traveling at over 200 miles per hour and going into a tight corner pulling over 6.5 Gs? Well, I will be demonstrating how tires and the body of a Formula One car could help make that possible. Formula One is one of the oldest racing competitions in the world, starting in 1950 and just turned 75 years old. Many high schoolers, like you, go into engineering at the ages 16 to 21. I have loved engineering since I started watching Formula One last year, rooting for who had the best and the fastest driver. Tires are one of the most important things of a Formula One car. These are the tires. There are ultra soft, super soft, soft, medium, hard, intermediate, and wet, making a total of 7 different types of tires made by Petroleum. The first 5 being dry tires, and the last 2 being wet. Formula One tires have enhanced grip, and over time, they wear out. And having these change during the race in pit stops helps reset tires and enhance their grip, and helps the rest of the car form to its highest ability. The Formula One car has very difficult aerodynamics created by Andrew Newey, who has been designing F1 cars for over 40 years, designing for McLaren, Aston Martin, Red Bull, and Ferrari. Formula One cars have DRS, drag resistant component or selector, ERS, which is energy resistant selector, and DRC, which is drag resistant component. I will now be demonstrating how a wind tunnel works, testing aerodynamics. So this tape is taped onto this Lego Formula One car, and this is how mainly Formula One teams test their aerodynamics with tape, and usually sometimes it's string or just smoke. Well, I can't use smoke in class because it'll set up the smoke detectors, but I have a fan here and I have tape on this Lego Formula One car. Now, when I turn the fan on, the tape will start to move, which is the air moving through and over the car using aerodynamics. The wind goes over the car, and as you can see, the ones on the sides, if you can't see, you can look, they move a lot faster because wind, when it moves on the side of the car, spirals, and which can also cause drag. Well, on most Formula One cars, there's cuts in the wings that suck in all the wind and cause the spirals to break, which causes less drag. And as you can see, the 2 front tape doesn't actually move because the wind is moving so fast over the tape that it doesn't actually catch it. Now, on the back is what's called the exhaust wind. The exhaust wind is after it's reached the end of the car and is now at the slowest possible. So, as you can see, the wind is picking up the sides a lot faster than the back and the front, and that's how a wing demonstrates how air goes through a Formula One car. So, and Formula One cars use carbon fiber, which is a light and very expensive material. In conclusion, a Formula One car is a very aerodynamic and stable car. Creating a Formula One car takes time and effort by all different degrees. Formula One is very consistent with keeping maintained and safe cars. Tires are one of the biggest things of a Formula One car, helping it stay stable on the track and make sure aerodynamics work to their peak. Wind helps push the car over and causes aerodynamics to work. Aerodynamics push the wind around the car to make sure that the car does not slow down going at high speeds. Wind still plays a purpose and still slows down the car slightly, but Formula One cars are so sleek and thin that they can actually go almost 7 times faster than a normal car. Now that I showed you how aerodynamics work, I hope that you can see and help aerodynamics get better in the future. Thank you for listening to my speech.